Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on trigonometry degree level chapter De Moivre's theorem, lecture number 11, in which I will solve some more problems. Now we solve a problem. Problem is 1 plus I x by a multiply 1 plus I x by b multiply 1 plus I x by c multiply equal to capital A plus I capital B. Then prove that 1 plus x square by a square multiply 1 plus x square by b square multiply 1 plus x square by c square multiply equal to a square plus b square, and tan inverse x by a plus tan inverse x by b plus tan inverse x by c plus equal to tan inverse capital B by capital A. Now we solve this. Let 1 equal to r cos theta 1, x by a equal to here r1 sin theta 1 implies that 1 square plus x square by a square equal to r1 square cos square theta 1 plus r1 square sin square theta 1, and this equal to r1 square common cos square theta 1 plus sin square theta 1, and this is equal to r1 square. Let this is number 1. Now we divide this by this, means r1 sin theta 1 by r1 cos theta 1. r1 sin theta 1 is x by a, and r1 cos theta 1 equal to 1, and this equal to x by a, implies that r1 and 1 cancel, sin theta 1 by cos theta 1 is tan theta 1 equal to x by a, implies that theta 1 equal to tan inverse x by a. This is number 2. Similarly, 1 plus x square by b square equal to r2 square, and theta 2 equal to tan inverse x by b. This is number 3. This is number 4. And 1 plus x square by c square equal to r3 square. This is number 5. Theta 3 equal to tan inverse x by c. This is number 6, and so on. Now 1 plus I x by a multiply 1 plus I x by b multiply 1 plus I x by c multiply equal to 1 means r1 cos theta 1 plus I x by a is r1 sin theta 1 multiply here 1 equal to r2 cos theta 2 plus I r2 sin theta 2 multiply 1 is R3 cos theta 3 plus I R3 sin theta 3 multiply dot 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 dot, and this will be equal to, we take common here R1 cos theta 1 plus I sin theta 1. Here we take common R2 cos theta 2 plus I sin theta 2. Here we take common R3 cos theta 3 plus I sin theta 3 and multiply dot 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 dot. This equal to R1 multiply R2 multiply R3 multiply dot dot dot. And by using De Moivre's theorem, this bracket multiply this bracket multiplies this bracket will be cos theta 1 plus theta 2 plus theta 3 plus dot 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 plus I sin theta 1 plus theta 2 plus theta 3 plus dot 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 dot, and bracket closed. Let this is number 7. Since given that 1 plus I x by a, 1 plus I x by b, 1 plus I x by c multiply dot 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 equal to a plus ib. This is number 8. From 7 and 8 we get R1 multiply R2 multiply R3 dot 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 cos theta 1 plus theta 2 plus theta 3 plus dot 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 plus I sin theta 1 plus theta 2 plus theta 3 plus dot 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 equal to a plus ib, equating real and imaginary parts of both sides. We get here real part is R1 multiply R2 multiply R3 multiply dot 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 cos theta 1 plus theta 2 plus theta 3 plus dot 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 equal to a, and imaginary part is R1 multiply R2 multiply R3 multiply dot 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 sin theta 1 plus theta 2 plus theta 3 plus dot 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 equal to b. This is number 9. This is number 10. From 9 and 10 we get a square plus b square equal to r1 square multiply r2 square multiply r3 square multiply dot 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 cos square theta 1 plus theta 2 plus theta 3 plus dot 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 plus r1 square multiply r2 square multiply r3 square dot 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 multiply sin square theta 1 plus theta 2 plus theta 3 plus dot 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 dot. We take here common r1 square multiply r2 square multiply r3 square multiply. Here remains cos square theta 1 plus theta 2 plus theta 3 plus dot 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 plus sin square theta 1 plus theta 2 plus theta 3 plus dot 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 dot. Here cos square theta plus sin square theta equal to 1. This equal to r1 square multiply r2 square multiply r3 square multiply dot dot dot, and this is 1. r1 square equal to 1 plus x square by a square. r2 square is 1 plus x square by b square. r3 square is 1 plus x square by c square multiply dot dot dot. This is 1. So first part proved. Dividing 10 by 9, we get r1 multiply r2 multiply r3 multiply sin theta 1 plus theta 2 plus theta 3 plus dot 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 by r1 multiply r2 multiply r3 multiply dot 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 cos theta 1 plus theta 2 plus theta 3 plus dot 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 equal to b by a. Implies that here r1 multiply r2 multiply r3 dot 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 multiply cancels. Only remains sin by cos, means 10 theta 1 plus theta 2 plus theta 3 plus dot 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 equal to b by a. Implies that theta 1 plus theta 2 plus theta 3 plus dot 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 equal to tan inverse b by a. Implies that theta 1 is tan inverse x by a, theta 2 is tan inverse x by b, theta 3 is tan inverse x by c plus dot 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 equal to tan inverse capital B by a. Second part proved. Now we solve the next problem. Next problem is x equal to cos alpha plus I sin alpha, y equal to cos beta plus I sin beta, z equal to cos gamma plus I sin gamma, and x plus y plus z equal to 0. Then prove that 1 by x plus 1 by y plus 1 by z equal to 0. Now x plus y plus z equal to x is cos alpha plus I sin alpha, y is cos beta plus I sin beta plus z is cos gamma plus I sin gamma. Implies that given that x plus y plus z equal to 0, this is 0 equal to right side we write cos alpha plus cos beta plus cos gamma plus, we take common I here remains sin alpha, here remains sin beta, plus here remains sin gamma. Since x plus y plus z equal to 0, since x plus y plus z equal to 0, this given implies that 0 means 0 plus I into 0. This is equal to cos alpha plus cos beta plus cos gamma plus I sin alpha plus sin beta plus sin gamma implies that this is real part and this 0 is real part. Cos alpha plus cos beta plus cos gamma equal to 0, real part equal, and here imaginary part sin alpha plus sin beta plus sin gamma, this is also 0. Let this is number 1, this is number 2. Now 1 by x, x is cos alpha plus I sin alpha, and this is cos alpha plus I sin alpha whole to the power minus 1. By using de Moivre's theorem, here negative power, so here we get cos minus alpha plus I sin minus alpha. Minus alpha means minus 1 into alpha. Here also minus 1 multiply alpha, minus alpha. And this is cos minus alpha is cos alpha. Here sin minus alpha is minus sin alpha. So here we write sin minus I sin alpha. This is number 3. Similarly, 1 by y equal to cos beta minus I sin beta. This is number 4. 1 by z equal to cos gamma minus I sin gamma. This is number 5. Adding 3, 4 and 5, we get 1 by x plus 1 by y plus 1 by z. 1 by x is cos alpha minus I sin alpha plus 1 by y is cos beta minus I sin beta plus 1 by z is cos gamma minus I sin gamma, and this will be equal to cos alpha plus cos beta plus cos gamma. Here cos alpha, cos beta, and here cos gamma minus I sin alpha plus sin beta plus sin gamma. Since cos alpha plus cos beta plus cos gamma is 0, this is 0 minus I into sin alpha plus sin beta plus sin gamma is 0. So this is 0. So proved. 1 by x plus 1 by y plus 1 by z equal to 0. Now we solve the next problem. Next problem is if cos alpha plus cos beta plus cos gamma equal to 0 equal to sin alpha plus sin beta plus sin gamma, then prove that sigma sin 2 alpha equal to sigma cos 2 alpha equal to 0 and sigma sin square alpha equal to sigma cos square alpha equal to 3 by 2. Now we solve this. Let x equal to cos alpha plus I sin alpha, y equal to cos beta plus I sin beta, z equal to cos gamma plus I sin gamma. This is number 1, this is number 2, this is number 3. Now x plus y plus z equal to cos alpha plus I sin alpha plus cos beta plus I sin beta plus cos gamma plus I sin gamma, and we may write the real part cos alpha plus cos beta plus cos gamma. Here imaginary part plus I sin alpha plus sin beta plus sin gamma. Here cos alpha plus cos beta plus cos gamma is 0 plus I sin alpha plus sin beta plus sin gamma is 0 given cos alpha plus cos beta plus cos gamma equal to 0 equal to sin alpha plus sin beta plus sin gamma, and this is equal to 0. Let this is number 4. 1 by x equal to 1 by cos alpha plus I sin alpha. This is equal to cos alpha plus I sin alpha whole to the power minus 1. This is equal to cos minus alpha plus I sin minus alpha. Cos minus alpha is cos alpha and sin minus alpha is minus sin alpha, minus I sin alpha. This is number 5. Similarly, 1 by y equal to cos beta minus I sin beta. This is number 6. 1 by z equal to cos gamma minus I sin gamma. This is number 7. Now 1 by x plus 1 by y plus 1 by z. 1 by x is cos alpha minus I sin alpha. Cos alpha minus I sin alpha plus 1 by y is cos beta minus I sin beta, and 1 by z is cos gamma minus I sin gamma. We may take real parts cos alpha plus cos beta plus cos gamma, and imaginary parts is minus I sin alpha plus sine beta plus sine gamma. This is 0 given 0 minus I into 0. This is 0. This is number 8. Now x plus y plus z whole square equal to x square plus y square plus z square plus 2 under bracket xy plus yz plus zx implies that x plus y plus z whole square equal to x square plus y square plus z square plus 2. We take common xyz. xyz. Here we have xy, so remains 1 by z plus here yz, so remains 1 by x and here 1 by y. Implies that since x plus y plus z equal to 0, 0 square equal to x square plus y square plus z square plus 2xyz and 1 by x plus 1 by y plus 1 by z equal to 0. So here 0 implies that x square plus y square plus z square equal to 0. This is 0, this is 0, only remains x square plus y square plus z square equal to 0. Since x is cos alpha plus I sin alpha whole square plus y means cos beta plus I sin beta whole square plus z square means cos gamma plus I sin gamma whole square and this is equal to 0. By Moivre's theorem, this is cos 2 alpha plus I sin 2 alpha. This is cos 2 beta plus I sin 2 beta. This is cos 2 gamma plus I sin 2 gamma. This is 0. Implies that we take real part cos 2 alpha, here cos 2 beta, here cos 2 gamma and imaginary part I sin 2 alpha plus sin 2 beta plus sin 2 gamma. This equal to 0 and 0 means 0 plus I into 0. Equating real and imaginary parts, we get cos 2 alpha plus cos 2 beta plus cos 2 gamma equal to 0 and sin 2 alpha plus sin 2 beta plus sin 2 gamma equal to 0. We may write in short, this is sigma cos 2 alpha equal to 0 and in short we may write this sigma sin 2 alpha equal to 0. So first part proved. Let this is number 9, this is number 10. From 9, we get cos 2 alpha means 2 cos square alpha minus 1 and sigma equal to 0 implies that sigma 2 cos square alpha minus sigma 1 equal to 0 implies that we may take 2 outside, 2 sigma cos square alpha minus sigma 1 means here 1 plus 1 plus 1 thrice 1 because this 1 is for alpha and another one is for beta and another one for gamma. 2 cos square alpha minus 1 plus 2 cos square beta minus 1 plus 2 cos square gamma minus 1. Here sigma means plus. So this means 3 equal to 0 implies that 2 sigma cos square alpha equal to 3 implies that sigma cos square alpha equal to 3 by 2. This is 11. Again, from 9 sigma cos 2 alpha may be written as 1 minus 2 sin square alpha and this is 0 implies that sigma 1 minus sigma 2 sin square alpha equal to 0. This sigma 1 means 3 and here we take 2 outside, sigma sin square alpha equal to 0 implies that 3 equal to 2 sigma sin square alpha implies that sigma sin square alpha equal to 3 by 2. This is 12. Therefore, here sigma cos square alpha equal to sigma sin square alpha equal to 3 by 2. Second part proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.